automotive industry is changing. As the automakers strive to build lighter, more fuel-efficient and rust-resistant vehicles, more and more body components are being made of plastic. In fact, by the turn of the century, it's expected that nearly the entire vehicle, from body to engine, will be made of plastic. As the result, your livelihood may well depend on your ability to do plastic welding. Some body men think the best way to deal with a broken plastic part is to replace it. But smart body men know that it's often cheaper, faster, and easier to repair the part with a Seelye hot air plastic welder. For example, by repairing the flexible bumper cover yourself, you will be assured of a perfect fit, and it will cost you 75% less than buying it from a recycler. By learning the hot air plastic welding techniques covered in this program, you will reap profits you may now be throwing in the trash or giving away. And you will be opening the door to a host of other plastic welding jobs that can earn you additional profits. They include repairs to snowmobiles, motorcycles, boats, recreational vehicles, farm fertilizer tanks, and a number of other plastic products we deal with in everyday life. During this program, you'll see the equipment needed to do plastic welding. We'll show you how to repair flexible bumper covers, wheel well liners, radiator tanks, batteries, bolt holes, grill bolt lugs, and other plastic parts, including interior parts. We'll also show you 3 simple methods that can be used to identify various kinds of plastic to ensure quality welds. You'll see why it's often faster and cheaper to repair plastic parts rather than buying new ones and wasting time waiting for delivery. Just by viewing this tape and spending some time with a Seelye electric plastic welder, you'll soon be on your way to increased profits and faster job turnaround. This is a Seelye electric plastic hot air welder, the device that makes plastic welding possible. It was among the first introduced in the United States and has been used successfully and profitably for nearly 3 decades. The ruggedly built Seelye welder heats air to about 550 degrees. It's this flameless stream of super hot air flowing through the welder's tip that softens the plastic welding rod and parent material into a bond that's as strong as the material itself. The Seelye welder comes complete with an air pressure gauge, air regulator, 110-volt power cord, and a ceramic heating element. The ceramic heating element, located in the barrel, is easily replaced. First, be sure the welder is cool, the power cord is unplugged, and the air is turned off before you take it apart. Then remove the set screw on the base of the handle and pull on the hose. Replace the element by simply removing the 2 lead wires and plugging in the new element. To ensure long element life and strong welds, it's important that your air supply is clean, dry, and oil-free. Contaminated air will result in less than satisfactory results. When setting up your Seelye welder, connect the air supply to the regulator first, but be sure the regulator dial is turned counterclockwise to the off position to prevent it from being damaged by excessive pressure. Set the regulator to 3½ pounds per square inch. Having air running before plugging in the welder will prevent the element from overheating and burning out. When you're finished using your Seelye welder, disconnect the power first and allow air to run for about 5 minutes to cool down the element. The welder does not have to be turned off when changing tips, but it is important that you use pliers for the job since tips get extremely hot. Tips should not be over-tightened, but should fit snugly. Over-tightening could make them difficult to remove once the welder has cooled. These are the 4 tips. The Seelye tack welding tip is perfect for use in aligning cracks in hard plastic for repair. Tacking allows you to provide for proper match and alignment of all pieces to be welded. It also serves to hold damaged sections together during actual welding. Tack wells can be easily broken apart without damage, and they can be retacked if necessary. The tacking tip should only be used for tacking. This is our round tip. It's especially useful where tight, sharp corners exist and for filling small gouges. The round tip supplies hot air to both base and rod material. This is the high-speed welding tip. It's best for repairing long, straight cracks. The high-speed tip preheats the welding rod in the feed tube and feeds rod to the weld. It's about 5 to 6 times faster than the round welding tip. The fourth tip used with the Seelye welder is the flat ribbon rod feed tip, which uses flat ribbon rod. It too preheats the welding rod in the feed tube and automatically feeds rod to the weld. It's used for repairing bolt holes and thin materials like battery cases and reservoir tanks. We'll be demonstrating the use of all 4 tips later. But first, let's discuss plastics. There are 2 major classifications: thermoplastics and thermosets. Thermosets are formed with heat and pressure, but their shape cannot be realtered by exposing them to further heat and pressure. Fiberglass is a good example of a thermoset material. Thermoplastic, on the other hand, is also formed with heat and pressure, but, unlike thermosets, they can be altered by applying heat and pressure. It is this type, thermoplastic, that we will be dealing with during this program. To determine whether you have a thermoplastic material, hold your heated welder with the round tip 1 inch from the material for about 10 seconds. If it softens, you have thermoplastic and the part is weldable. If it doesn't, other repair methods are necessary. There are 5 types of automotive thermoplastic materials currently used: polyvinyl chloride, PVC, polyethylene, PE, polypropylene, PP, polyurethane, TPUR, acrylonitrile butadiene styrene, ABS. Before a part can be welded, you must identify the type of plastic it is made of, because it must be welded with a like kind of rod. There are 3 methods for identification of plastic parts. The fastest and easiest is to look for the code letters molded into the part. In this case, it's PP. As a result, a polypropylene or black rod would be used for welding. Rods are color-coded for easy identification. Check the code on the Seelye chart to select the color which corresponds to the type of plastic you'll be welding. Note that rod color does not necessarily correspond with the color of plastic you are repairing. A burn test is the second method used for identifying kinds of plastic. That's done by first removing a sliver of parent material, holding it with a pair of pliers, and lighting it. Various kinds of plastics burn with different colors and smells. The Seelye chart may be used to identify the various burn characteristics. Polypropylene, PP, burns with visible smoke, an orange flame, and has its own distinguishing, sharp, acid smell. Polypropylene will continue to burn when flame is removed and it floats in water. Polyethylene, PE, burns with no smoke, an orange flame, smells like burning wax, and melts, swells, and drips. Polyethylene will continue to burn when flame is removed and it floats in water. ABS burns with a thick, sooty smoke. It also continues to burn when flame is removed. ABS has its own distinguishing sweet smell. Polyvinyl chloride, or PVC, is self-extinguishing. Do not inhale fumes. Polyvinyl chloride will char and give off gray smoke. The 5th kind of plastic you can weld with your Seelye welder is polyurethane, whose code is TPUR. Polyurethane is the most flexible of the 5. It burns with a sputtering yellow-orange flame and gives off black smoke and continues to burn when flame is removed. If you choose not to use the burn test, we recommend the trial and error method if the manufacturer's code letters can't be found on the part. Trial and error is done by cleaning and then softening a small sample area on a hidden side of the material along with the rod you think is compatible. When the two are pressed together and allowed to cool, they will bond tightly if they are compatible. Incompatible materials will not adhere. With some experience, you'll begin to learn that various automotive parts are made of certain kinds of plastic. Bumpers are usually polyurethane. Fan shrouds are polypropylene. Catch tanks are polyethylene, and radiator tanks are glass-filled nylon. Before we show you how to repair various automobile parts, here are some tips to follow for doing quality welds. Degrease and clean all surfaces to be welded with a wax and grease remover. Don't attempt to stretch the rod over the weld. The length of the rod should match that of the weld. This is accomplished by pushing straight down on the rod. Look for small beads of juicing to form along each side of the weld where the rod meets the base material. This lets you know the rod and material are at proper temperature for welding. If the rod or material chars or discolors, they've been overheated and you'll get a weak weld. When heated to the correct temperature, the finished weld bead will have a round contour. The rod will hold its basic round shape. To ensure that parts are properly aligned, always tack them before welding. The only exception to this rule is when you're dealing with polyurethane parts like bumper covers. Then use aluminum tape on the back of the part to hold it in alignment. Let's begin bumper repair. Remove or feather the painted surface back about a ½ to an inch on each side of the crack. Grind or cut a V along the crack, matching the diameter of the rod you'll be using. Be careful not to build up heat on base, which will cause a glaze and a poor weld. The V should be cleaned with wax and grease remover. Using the round tip, weld along the crack. Be sure to soften both the rod and base material to ensure a strong weld. Avoid excessive juicing during the procedure. It indicates that the weld is too hot. Once the weld has cooled, remove the jig and grind off excess rod with slow speed grinder with a 60 to 80 grit disc. Don't let too much heat build up while you're grinding or you may cause the material to warp. That's all there is to it. From here, fill the small cracks and pinholes with a flexible glazing putty, prime and repaint the area according to the paint manufacturer's recommendations. Distortions can be removed with a hot air heat gun. Total repair time should run about 30 minutes. We estimate that you can repair a bumper for about 25% of what it would cost if you were to give it to a bumper recycler and then buy it back. And by repairing it yourself, you know the job is done right, so you're not dependent on someone else for quality control. Best of all, because you're repairing the original bumper, you know it will fit properly when you're finished. Plastic wheel welds or fender skirts are made of polypropylene. For best tacking results, it's sometimes necessary to clamp the parts together. Begin the repair by channeling out a groove or bevel in the broken material. This gives the welding rod a place to fill. The job can be done with a knife or a power hand grinder. Using the welder with the tacking tip, form a hinge bond between the two edges. That's done by drawing the point of the tip firmly along the joint to be welded and pressing evenly on both sections. The point of the tip will fuse a thin line along the joint at the root gap to form a small hinge and help ensure a uniform weld later. Next, using a pair of pliers, remove the tacking tip and screw in the round or high-speed welding tip. We are using the high-speed tip. Begin the job by cutting the welding rod at a 60-degree angle and then inserting it into the feeder tube of the welding tip. Hold the welder so the rod is 90 degrees to the work. Then, using the curved foot of the tip, press the end of the rod into the weld. Move the welder forward along the weld and drop its angle to 45 degrees. Feed the welding rod manually into the feed tube until the weld bead is well started. The rod will then feed automatically as you exert firm downward pressure on the tip. Once started with the high-speed tip, you must keep moving since the tip is continually softening the rod. To stop a high-speed weld before the rod is fully used, set the end of the weld with firm pressure and draw the welder off the remaining rod. Cut the weld bead with a knife. Be sure not to leave the welding rod in the feeder tube, or it will melt and clog the opening. Occasionally, it will be necessary to clean the feeder foot with a wire brush. After the weld has cooled, use a DA sander or grinder to remove excess rod. Finish the job by painting the weld with flat black paint or undercoating. As you can see, it really is fast and easy to plastic weld, and it's equally as fast and easy to replace plastic parts that are missing. For this demonstration, we're using a wheeled weld liner. The hole has been cut to make clean edges. Begin the job by tracing the shape of the part you'll need on a piece of scrap material of the same kind. Cut the replacement part with a pair of cutters and check the fit of the new part. As demonstrated in the last example, bevel edges of the material to accommodate the welding rod. Using the tacking tip, tack the replacement part in place. Finally, use the round welding tip to complete the job. Begin round tip welding by selecting the proper welding rod and cutting the end to a 60-degree angle with cutting pliers. Hold the rod at right angles to the work and heat the tip of the rod with the tip. Once the rod and base material are tacky, press the rod firmly into the joint with the point of the rod away from the direction of the weld. It's important to get a good start, since it's the weakest, most difficult part of a weld. After the initial bond has set, heat the welding joint and rod together with a slight fanning motion in line with the direction of the weld. Keep a firm downward pressure on the welding rod at right angles to the work. As the weld continues, you'll see a small bead forming along both edges of the weld, and a small roll forming ahead of the welding rod. Both should continue along the entire weld joint. When you reach the end of the weld, hold the rod down briefly, then cut the excess rod with a knife or snippers. Small cracks and patches like this one can typically be done on just one side of the part. The whole job will take about 30 minutes to complete. Cracked or broken batteries can also be repaired with your Seelye hot air welder. Before you begin the job, put on a pair of safety glasses and gloves and carefully empty acid from the battery. As shown in previous demonstrations, clean the surface. If this repair were being made on the edge of the battery rather than on its side, we would recommend that you use a round welding rod. If the repair is to be made on the side of the battery where the plastic is thinner, we suggest using our flat ribbon rod. When using the round tip to apply the ribbon rod, use a horizontal fanning motion to heat the rod evenly. You can also use our flat ribbon feed tip. As with the high-speed welding tip, the rod should be fed into the feed tube manually until the weld bead is well started. The rod will feed automatically as firm downward pressure is exerted. As we showed earlier, ribbon rod is also very useful to repair bolt holes. Radiator tanks are just as simple to repair. As with past repairs, groove the crack to make room for the welding rod. Using a glass-filled nylon or Noril welding rod and the round tip, repair the crack. Remember to cut the rod at an angle and heat it and the parent material until it juices. This rod requires more heat than the others. Sometimes this repair can be made without even removing the tank from the car. Total repair time should run about 15 minutes. You'll find that in the long run, it will be cheaper to use your Seelye plastic welder than to use structural adhesives, which require continuous purchase of adhesive materials. In addition, adhesives don't offer the flexibility and resistance to temperature that you get with thermoplastic repair. Heat welding also saves time during finishing, because once the joint is cooled and sanded smooth, it can be painted. There's no curing time. Insufficient curing of adhesives can result in bullseyes in the paint. Best of all, you don't have to worry about the health hazards associated with isocyanates found in some structural adhesives. For our final demonstration, we are going to repair this door panel, a job that's substantially cheaper than replacement. The panel is made of polypropylene, and like other thermoplastic olefins, it's not repairable by the use of adhesives. As shown earlier, groove, clean, and tack the crack. Then make the repair on the front side using a polypropylene rod. Once cooled, you're ready for finishing. Begin by